All right. This video is going to talk about function operations. Function operations are basically just taking basic functions like adding, subtracting, multiplying, and dividing. Only we're going to not apply them to arithmetic, to basic numbers. We're going to apply them to actual functions. So you'll notice up top here, we've got f of x and g of x. F of x is equal to x squared plus 3, and g of x is 2x minus 5. And the first thing that we want to do is find f plus g of x. Now, that might look a little bit different, but again, it's just basic function notation. If f is a function of x and g is a function of x, note the x in parentheses there, it's just saying that x is the variable inside of this larger, broader function. Well, the same thing goes down here. F plus g is saying we're going to add the two functions, but oh, by the way, they're both functions of x. If you want to write that a little bit differently, that's perfectly fine. What we can actually write is f of x plus g of x. Again, it's just a little bit different way of looking at it. Those two, things mean the same thing. Which means what we really want to do is take f of x, which was again x squared plus 3, and we want to add on, right? We're just doing a sum. We add on 2x minus 5, and basically it just comes down to adding some like terms. So we've got an x squared, we have a 2x, and we have a common term, so 3 and negative 5 would be a negative 2, and that becomes f plus g of x. The same thing goes for the three functions down here at the bottom. So notice we've got f minus g of x, so we can say, again, that's f of x minus g of x. Now you got to be a little bit careful when it comes to that. Remember, you're subtracting the entire function g of x. So we want to take x squared plus 3, right, f of x, minus, in parentheses, always a good idea, 2x minus 5. I need to subtract all of that function g of x. We could have used those parentheses up top as well. It's just with addition, those parentheses don't really do anything. Same thing goes for f of x in this problem. Again, I could put parentheses there, but they're really not doing anything. What we really want is x squared plus 3. Then I'm going to distribute that negative. Minus 2x, negative of minus 5 becomes plus 5. And we can kind of squeeze this in here. We've got an x squared minus 2x plus 8 this time. So notice we get a slightly different function than we did when we were adding. Now, right below that, you'll notice we want f minus g of 5. Now, we could find f of 5 and find g of 5 and then subtract. But since we have a new function right above there, basically we just want to plug 5 in for x. So this is going to become 5 squared minus 2 times 5 plus 8, which is going to come out to 25 minus 10 would be 15, plus 8 is 23, and we get our final answer. Because we have that new function already set up, we're in good shape there. Now, an option for the ones in the middle, though, as I kind of mentioned, well, what if we did want to just find that number? What if we start with that and then we'll go up top and we'll find that multiplication next? So notice again, f times g, there's no symbol at all there, but we know, and when we're multiplying, no symbol is needed. So what I really want to find is f of negative 2 times g of negative 2. And so it's totally our option. We don't have to construct that whole new function first. We can just find those two numbers. So f of negative 2 is going to be negative 2 squared plus 3. G of negative 2, right, is going to be 2 times negative 2 minus 5. So again, we've got 4 plus 3 is 7. And over here, we've got negative 4 minus 5 would be negative 9. So times negative 9, and a final answer of negative 63. Well, we could, again, up top, find f times g, or f of x times g of x, if we like. But again, that's going to take a little bit of algebra. We've got x squared plus 3, 2x minus 5. We're going to have to FOIL a little bit, so x squared times 2x is going to be 2x cubed. We've got an x squared times negative 5 is minus 5x squared, plus a 3 times 2x is going to be 6x, and then a 3 times negative 5 would be negative 15. So again, we get a much larger, 4-term polynomial essentially going on down there. And if we plug negative 2 into that function, let's hope this works, right? Let's hope I did all that math right. If we took out x and we plugged in negative 2, notice how much work that is this time. Again, we can pump that into the calculator. Negative 8, though, times 2 in that first term is going to be a negative 16. Positive 4 times negative 5 would be a negative 20. So again, we've got negative 16, right? Minus 20 is going to be a negative 36. Minus another 12 would be a negative 48. Minus 15, I believe, comes out to our negative 63. So we get the same answer either way. It would just depend on what method you wanted to use to do that. The last one over here we've got is division. And again, that's basically just saying take f of x and divide it by g of x. Well, this time we won't be able to do a whole lot, but we've got x squared then plus 3 divided by 2x minus 5. And because that top polynomial x squared plus 3 is not really factorable, we can't really divide anything. Really, that setup is our answer. But this does bring about the fact that sometimes we do talk about the domain of these functions. Normally, for these functions, adding, subtracting, multiplying, not a lot of craziness usually happens. Notice that in f of x, we're squaring something and adding 3. So really, I'm thinking my domain is going to be all real numbers. And similarly for g of x, 2x minus 5, we're multiplying and subtracting. There's really nothing going to stop us. So we could say all real numbers, or again, if you want to write interval notation, right, we can say negative infinity to infinity. Either way you represent it, we can plug whatever we want in there. However, because of the division over here, now that 2x minus 5 is in the denominator, I need to make sure that that doesn't come out equal to 0. So I would want to set 2x minus 5 equal to 0. And I would want to make sure that, again, 2x equals positive 5, x equals 5 halves. I would want to make sure that for my domain, my x value is not 5 halves. Otherwise, I'm going to end up dividing by 0. So therefore, the domain, again, is all real numbers except for that 5 halves, or 2.5. Or again, if we wanted to do some interval notation, negative infinity up to 2.5. And from 2.5 up to infinity, I just can't use 2.5. Now for that one, we really only had to look at the final function, but you do want to be careful. Notice how at the beginning, again, we had found the domains of f of x and g of x. If there is a number that can't be used in the original domain, so let's consider these two functions. F of x, I would definitely have to have x be greater than or equal to 0 because it's under a square root. For g of x, the same thing goes. We're underneath a square root. So I can't use essentially negative numbers right now. We can't plug in negative numbers or we won't get back real answers. But what if we went to find, again, f times g of x? Well, that's going to be 3 the square root of x times 5 the square root of x, which basically comes out to 15 the square root of x squared, or 15x. Now, many folks will tell you if you take the square root squared, we're forcing that to be positive, so we should put some absolute values around that x. So to be technical, you're correct, we should be doing this, but most of the time we kind of get to ignore those facts. A lot of times the book will say, well, hey, x had to be positive, right? So we didn't have to worry about that. The key though is when we go to find the domain, we can't ignore the fact that at the beginning, we couldn't use negative numbers. So even though 15x, I could plug whatever I want in there, 15 times any real number is going to be a real answer. Because the original two functions couldn't have negative numbers, the domain of my new function is also that we can't use negative numbers. Or basically, we're going to have to say from 0 to infinity. Right? We can only use 0 and up because of those initial square roots, because of the functions f of x and g of x when they started. I hope that helps a little bit with function operations. If you have any questions, make sure you talk to your teacher. Otherwise, have a great day.